Recording. Okay, so I improvised a presentation like much quicker than I ever wanted to. Might be a bit incomplete once here and there, but yeah, please excuse me. So molding and casting. This is kind of my favorite assignment, and let me see. I have a lot of links for you. If you want to have a laugh, look at my molding and casting. This was my FabAcademy 2013. I made this.
Ferdi, you're not sharing your screen, I think.
Oh, wait. Sorry. Better? Okay. Let me do this here. Okay. Yeah, here's a little collection of links. The first link is to my assignment from FabAcademy. I tried to model this one piece of a gearbox. I had a model in OpenSCAD that I could adjust a little bit, and you can see all the mistakes I went through, which might be interesting, like bubbles, incomplete filled molds, the little tools I built for helping myself. Yeah, I will talk more about the mistakes because actually the mistakes is the most important or the most interesting part. Then there's a really good mold making class on Instructables. It's mostly about copying existing parts, so it's not covering the part that we're going to do where we 3D mill a model. And so I will mostly skip everything that is not topic of our class today. There's lots of awesome tutorials and classes on how to make molds, starting from like little props that you already have. Like this one, where they make a copy of a finger hood, like the little thing that you stick on your finger for not when you're sewing. You see those tiny little things? But this is kind of the size that I want to focus on in the beginning. Like we don't want to make big parts for learning. And
the thing you're looking for, the name you're looking for, is a thimble.
A thimble. Okay.
Thimble. TH. Thimble.
Thimble. Okay.
Yeah.
And finger hood.
Yeah, finger
hat.
The thimble. Yeah, you have to be careful. It's used for sewing, not suing. For suing, you need a lawyer.
Okay, thank you. Yeah. This lecture is from Saverio Sili. He's just the master of molding and casting in FabAcademy, and he made a bunch of very nice videos and a few tutorials in PDF. They're really awesome. He comes from the model making business, so he talks a lot about some techniques that we're not going to use but are very interesting. Let's see, maybe we can quickly skip through his slides as well. Yeah, very recommendable. And my favorite one is this one. It's called Guerrilla Guide to CNC Machining. And now I'm already in chapter 2 or something. If you go to the very first slide, let me see. You can choose between having the whole thing in different chapters or simply seeing all of them at once. And so the whole thing is lengthy. You can see the length of my slider on the right side. He covers everything, like from what's a CAD program to what type of machines to use. It's worth to have a look in remarkably cool and precise designs. Just quickly jump to this one, if it opens. So he's building what he calls the Omnibot. And this is, for example, a gearbox for a little motor and this is the mechanism of it. It's tiny, like the whole thing is maybe 10 millimeters in diameter. This is the molds that he makes and the parts that he casts. So it's really very tiny, very highly precise stuff. It's beautiful to see it working, and it's also awesome to have a gear reduction this small. And I couldn't think of any other way of producing this. Like 3D printing is far away from that. Yeah, so have a look. This is just beautiful. And here you see the little model. Okay, and then so this is the examples, and this is no. How do I get back? Here. And this is the whole thing. So he goes, like he uses what they call chemical wood. It's a special type of polyurethane resin. It's one-time use only, so once you cut it, that's it. But it's very highly detailed and very, like it has a lot of advantages. The only disadvantage is the price. Then he goes through all the different mills and all the different problems you can run into with them. And I think at some point he also has a photo where he shows some detail of how small he can go, and it's really amazing. Let me see if I find this one. Yeah, he also like repeats everything that we know already, like milk and climbing cut and conventional and yeah, this is yeah, here you can tell like this is 1 millimeter, so those teeth are really tiny. Okay, so this is the Guerrilla Guide to CNC Machining. And then there's also a lot of tutorials from like, you know, the
Ferdy,
mold makers.
before you go
Yeah.
on, how strong is that wood?
It's not very strong. It's like, you know, the dense foam that we have.
Yeah.
Yeah.
Okay, it's like that.
This is I would say the wood. It's about as strong as wood, and but has similar properties to the foam. So it mills as easy as the foam,
Okay.
but it's as solid
Okay.
as a piece of MDF, or maybe even more than
okay,
MDF.
all right.
Yeah.
Okay. Just because I need to make some tiny brass gears, and this isn't going to be the way to do it because the forces are too high. But
I think the wax
about it
is also really good.
Okay.
So, and this is the stuff that we're using, that we have in the lab. And those carving waxes, they come in 3 different colors. Like this is also used extensively excessively in jewelry making. And people carve it by hand, or they there's actually, you can buy this also like a glue stick, so you can put it in a little pistol where you can just squirt a little bit of liquid wax. You can already buy pieces that have the shape of a ring, so you can easily just cut pieces and make rings. It comes in 3 different colors, in pink, green, and blue. My favorite one is the blue one because it's the most flexible one, so the most forgiving. Like if you mill like a thin, tall feature and you accidentally hit it with your mill, this one, it might just flex back. Whereas the green one, which is the most rigid one, that also allows you the highest detail, is it will just shatter. So the blue one is detail-wise high enough for anything we're making, and it's the most forgiving one if you bump it a little bit. Then here we see again like some of the like in the Guerrilla Guide to CNC Machining, there's a long list of all the different chemical woods that he's using. So one very common one is this Wen shape 460, and there's like a whole collection of different Wen shape chemical wood. And then there's a few other brands, like from Axon. The Sika Block is also very well known. And I'm sure this is all American brands, and I bet you get the same in German brands again.
Freddy,
Yeah?
I have a question. I mean, this material, the mold, it doesn't really have to, doesn't need to have much resistance because, I mean, it's just the form into which I pour my resin, right? I mean, why would I want to use a hard resisting material in the first place? I don't see the point.
The choice of this material is very important. Like most other materials that you could possibly use, let's say you say, oh, I make it from wood. And actually, I think Daniele made his mold from wood. But then first problem is you will see the texture, the grain of the wood will appear in your pieces. Second problem is if you want to vacuum degas it or similar things, there will be air coming out of your wood, and it will go into your silicone, and you will have air bubbles in your silicone. You want something where the silicone releases from nicely, something where you can put a release agent on so it goes off. If you put release agent on wood, it will start to swell up and you will destroy your mold in the first place. Like this chemical wood won't do that.
In our case, so it was just because we didn't have the wax.
Yeah. That's like for me in Portugal, it was really hard to get this wax. I had to figure out that I have to buy it in the jewelry stores, and there's exactly one jewelry store in Lisbon where you can buy this. And so yeah, I spend a lot of time going by bike and searching for alternatives, and I'm still looking for alternatives to this wax or to this chemical wood, and I still haven't found one, not a single one.
So I think Kai's question was more about the three different types of wax. You have the blue wax, the standard one, and then you said there are stiffer. I presume the green is a stiffer wax.
Yeah.
The difference is going to be in the ability to make really fine detail, isn't it? The softer wax won't carry the super fine. If you tried to carve that softer wax with a 100 micron milling bit, like we have for the what do you call them, PC boards, to make super detail at that level, you wouldn't be able to do that in the blue. It would just melt. Whereas in the green, it was just stiffer and harder. You'd be able to get a better. Am I right with that?
Yeah. So here, like, if you go to machineablewax.com, you can see like the different choices. You can buy it as a powder. You can buy it in cylinders. You can already get it like, especially for dentists, for milling like your teeth. Then you get it for jewelry already in shapes of like differently sized blocks, and they should also have like the ring templates, which I don't see right here. Maybe it's the tubes. Yeah, this is like especially for ring making. They also have one which is just like a bit simpler and more similar to a regular ring, and yeah. So and then there's this little pistol. And you can also get it like leftovers for cheaper. Yeah, so there's the choice in waxes is quite big, and here they don't really talk about the rigidity of them, but yeah, believe me, the green one is the most rigid one, and the rigidity. It like if you imagine you're milling a pin, like a needle, and you want to have like the top of the needle is supposed to have like a face. So now you need something where if you have the pin standing up and you want to mill the top, that doesn't flex the needle top forth and back when you're milling on it. So you want something that is very rigid and doesn't move. And
I have one more question. One more question about the material.
Yeah.
Is this would this be okay also for casting food? Could I pour chocolate into that, and it would still be okay to eat?
Ah, wait. Like we will get to the naming in a second, but what we're talking about right now is is the master, the model. This is not the part where you pour any final result in. This is just the precursor to making your copy.
Okay. Mm-hmm.
Okay. Yeah. So yeah, materials like of course you could use almost any material. Also, this foam that we're using is would be usable.
Yeah, but hang on. You know that he could be. I mean, we could have interpreted Kai's question as he wanted to make the mold out of chocolate. Now that would be fun.
This would be fun. Also, I like talking.
I mean,
about,
it's chocolate teapot stuff, right? It's all,
yeah.
But it would be fun.
Another
then you'd have an edible
option,
mold. What a great project!
Another interesting option would be soap.
Keep that in mind.
Soap is a lot cheaper than this machinable wax, and it has similar properties. But since we're at this right now, I could also just quickly jump and remember the name of my student in Lisbon. Just a second. Where did my bookmarks go? F11. So yeah, it's just gonna be FabAcademy. And this should be 2014. And this was in Lisbon. Bruno Mauricio. So he made his own wax, but unfortunately I think he didn't. Oh, this is the regular offer from one of the most well-known companies, Smooth On. So this is really nice to see, and there's Fab Labs where the shelf looks like this. And yeah, so this is his self-made machinable wax. And he has another bunch of pictures documenting this process, but they're not, unfortunately, they're not in molding and casting, but hidden somewhere else. Is it here? Like he wanted to cast something quite big. He made like an extension cord that you can remote control using this networking module from Neil. So the idea was that you can just daisy chain them like this, and then by talking serial to them, turn different parts of the chain on and off. And so he wanted to cast these quite big pieces, and we didn't have enough money for buying this much wax. So he started pouring his own wax, and here you can see parts of the process. So the idea is that you melt paraffin wax. Like paraffin wax is maybe €5 the kilo. It's quite cheap, but it's the same wax that you use for those those small tea candles. That's the same stuff, and that's far too soft. Like if you would try to mill it, it would just melt next to your mill and then re-solidify right after it, and you wouldn't be able to take it out of your mold. It would just smear all over and look horrible. So the idea is that you take HDPE plastic bags and you throw them into your paraffin wax and melt the whole thing, so that the paraffin wax kind of unifies with the HDPE, and you get a more rigid paraffin or wax, and then you get chips when you mill it instead of just getting like a smeary mass. The problem is like they don't always unite as nicely as you want them to. So here you can see like it's a bit white and a bit waxy. But in the end, he developed a technique that worked quite well. The trick seems to be the way, like you have to cut strips of the plastic bags, and the way you drop them into the liquid wax is important. But yeah, this pot caught fire, and he was clever enough for not pouring water over it. So he just put a lid on, but after 10 minutes, he opened the lid, and the wax also emits fumes that are ignitable. And so suddenly it went woof, and the whole thing basically exploded. Like even all the gas that collected in the room just went on fire. And with the shock that he got, he probably tripped over the whole thing and poured it over his hand, which left him burn marks that he will probably keep for the rest of his life. So yeah, be careful, wear your protective equipment. Here you can see this is the setup in the Fab Lab in Lisbon. And here you can see a video of him pouring the stuff. Like in the end, he got really good at it. But yeah, this picture looks more peaceful than it is.
Is that before or after he got back from the hospital?
This is before still, yeah.
Dear.
Let me see if you can see the strips somewhere. Like the way you prepare it is quite important. And this looks beautiful. I will also add the link to our presentation.
So that's paraffin and HTFE, you say?
HDPE. Like
PE.
you know, from the plastic bags, there's the one that if you move them, they make a sound, and the others that don't. Like the ones that don't make a sound, this is LDPE, low density polyurethane, and the ones that go like this is the HDPE, like the high density polyethylene.
So
and this
the
is
cheap
the one.
stuff.
Yeah, that's what you want. Yeah.
Okay.
And let me find my presentation again. Where is it?
Did this guy complete the FabAcademy or?
No, I think he still hasn't completed. Like he gave it another 3 or 4 attempts, but I think he still hasn't finished. But he was at some point he was working for the most famous artist in Portugal. I don't know if you know. Yeah, he made a career even without finishing his FabAcademy. Just by showing what he did up to this point, he got a few quite good jobs. Now I don't remember the name of her. I got to visit him in the workshop of the artist, which was very interesting. Joana Vasconcelos. Sorry, I'm side tracking. And actually, it's not Joanna. It's Joanna. Like she makes crazy stuff. Like if you're interested, like have a look. She also does molding and casting. So okay, sorry. Back to the presentation. So we're still at the materials. So what type of silicone resin do we use? And as I said, Smooth-On is like they have a huge choice, and it's a good idea to have a look on their website, because they also have lots of interesting tutorials and webinars and like if you look at their choice. Oh yeah, right now they're of course making rubber masks. So these are the main categories. Silicone rubbers, this is what we're going to use. Urethane rubbers, and then there's other rubbers and resins, but we are mostly gonna be working with the silicone rubbers. And if you're in Germany, Kaupo, they're basically resellers of Smooth-On. So they sell the same stuff for maybe a bit more expensive. But they also have but this is the only one in Germany I know. And yeah, the stuff is not cheap. Like the silicones are usually somewhere between 30 and 60 euros the kilo. But there's no real alternative. I found some interesting stuff from dentists. Like actually the cheapest silicone that is food safe, I bought it at a German dentist that just started developing his own resins, and they're only 30 euros the kilo. I have some tricks for making something even cheaper, but this I will show you. It's not really part of FabAcademy. Okay, so this is where am I? Yeah, if you buy stuff, it's like there's a few lives that are important. One is the shelf life. So starting with production, the stuff starts to degrade. So if you're unlucky, you might accidentally buy something that is already old. So if you buy something, make sure that you know the production date. Because if you buy something that has already been lying in the shelf for half a year, you can basically already throw it away before ever opening it. And so the shelf life does not depend on whether you open it or not. Actually, it doesn't care at all about you opening it. Once you buy it, or once it's produced, the clock is ticking, no matter if you open it or not. If you buy it and it doesn't have a date on it, it's already strange. First thing you should make sure is that you write a date on it, even if it's just the date you bought it. Still better than nothing. And of course, the lifetime varies with temperature. Like the warmer, the quicker it goes off. And yeah, other stuff can also affect your shelf life. Also, storing it depends on what you store it next to. Like if you store the hardener and the silicone in the same shelf, this might take down your lifetime. And then so there's shelf life, and then there's pot life, and this is the next thing you have to look on very carefully when you buy the stuff. Because the pot life is the time you have between mixing and pouring of your material, and this can vary between minutes and days. So if you look at those guys pouring like really big quantities, you don't want a silicone with a pot life of like 5 minutes. You want something where you can take your time and prepare all your stuff slowly, and it doesn't cure like halfway you pouring it. But then there's, for example, for the resins, there's resins that cure in like 5 minutes. So you want to mix and pour them quickly, but then you can make a new part every 5 minutes. Yeah, most cases I would go for a longer pot life, but this also mostly means that the cure time is longer. But yeah, like what you have to learn with molding and casting also is patience. Like it can go quite quickly, but most of the time you have to wait until something dries or until something is cured. Okay. Yeah. So if you look at the presentation from Saverio, you will see that he goes through a much wider range of different molding and casting techniques. So you can make molds from cardboard and paper. Like maybe I think I still have this open here. So there's all kinds of techniques. Like this is slip casting that you use for making ceramics. This is how you make the Lego pieces. There's casting of glass. There's 1, 2, and many part molds. I'll just quickly jump through this. But the only thing I'm going to cover today is like very simple one-sided molds. And like this is all very fun and nice to do, but this is not what Neil wants to see this week. Neil wants to see us milling wax with a a 3-axis strategy. But all of this, like making folded molds, is super awesome, and I would really like to spend some time playing with all these different techniques. But we should make our duty mold first. This one is quite awesome. It's like made from like many layers of paper, and yeah, this must have been a complete nightmare time-wise. Like this is probably a week just for making the mold. Yeah, this one is made of mushroom. In the end, the mushrooms are growing out of it. Yeah, so there's many interesting techniques. Today we're just gonna cover the most simple one. Okay, for the naming, so to make sure that we're all talking about the same stuff, like the first part that we want to produce is our model or our master. Who has the squeaking door in the background?
It's me on the school chair.
Okay. So in the prop making industry, your model master is mostly something that you just build yourself, like from wood or from foam, or maybe you glued together some pieces that you want to copy. Yeah, but in our case, it's going to be the master is a piece of wax, and it has the positive shape of our final model in it, at least from one certain direction. Then there's the mold, which is the silicone part that you poured into the master. And once of course, there's, in this case, there's 2 masters, like one for one side. This would be fab. And there you don't see there's another wax model that says LED. And then once you have those 2 molds, you can make the cast or the copy. And if you, like in mechanical engineering, I learned a lot about metal casting. And in metal casting, the vocabulary is even a lot bigger. And so, for example, the part where you pour it is the pouring basin. Then the part where it runs down is the sprue. And then the one that distributes it are the runners. The ones that connect to your part are the gates. And there's like very detailed, like just this pouring basin, there's like a DIN norm for it, and it tells you which angle the sprue has, what radii this pouring basin has. This is all like very highly sophisticated stuff that we don't have to go into very much, but it's good to know that there's a word for every little detail of what we're doing. And
presumably there's also a DIN norm for pouring wax too?
I wouldn't be surprised. Yeah, we can have a look. Yeah. Like one of my first jobs was to build a machine for injection casting wax into a silicone mold, and the thing just the piece where you clamp the mold for sticking it to the machine that injects the wax weighed maybe 200 kilos.
Yeah.
Yeah. So it's yeah, and we built a Peltier cooling module for it that would cool down the whole thing in 2 minutes. So you could freeze a Coke can in like it had like 600 watts in cooling power. Okay, so yeah, then first considerations. What model do you want to choose? And I had a laugh because like model, this was my Brazilian supermodel. Like she was one of my students in Barcelona, and she decided to cast her mouth in chocolate. And so there's this special, it's called flax wax. It's a type of wax that melts at a very low temperature, and you can actually smear it on your skin without burning yourself. So we made her quiet for the first time ever. So you apply it to your skin, and then we put it into the modella, into the milling machine that has a tactile scanner, and we scanned the piece of wax for making the mold, and we were casting pieces in chocolate. Since we're already at body parts, one of my students decided to make noses, so she made how do you call this, Madalena, like this fluffy type of biscuit. For some reason, her idea was to make Madalena noses, and she did. This one was also a nice idea. He made, this is a scraper for surfboards. Like if you're surfing, you use what they call the sax wax, which is so you don't slip with your bare feet on your surfboard, but you need something for applying the wax and for scraping it off again. Yeah, so I'm just going through like a random mixture of models. This was the one that I made. Then those are quite popular, like those silicone molds for making ice cubes. But don't expect your ice cubes to look like this. This is not made from water. If you want ice to freeze transparent, you have to move it while it's freezing. So maybe you know those ice cubes that look a little bit like shot glasses? Those are probably one of the few ones that are actually transparent. And they are made in a special fridge which constantly moves your water forth and back. Like it's the whole tray is movable, and it's constantly rocking so that it freezes transparent. You could build something like this with a little servo in your fridge, but it's not as easy as it looks on the pictures. Yeah, if you Google for ice cube molds, or also for chocolate casting, you will find a lot. And what's also nice
we have some of these for the what's it called, Gin and Titanic.
Yeah, okay.
So it's some submarines and some Titanics. Icebergs and Titanics.
Nice. Yeah, the good thing about molding and casting is that you can make as many copies as you like. And so there's lots of artists that like you make one mold and you cast 20 copies and you paint each one in a different color, and you can sell them as unique art pieces, which seems to be quite fashionable recently.
When you guys were working on the face shields, one thing that's really confused me, or I didn't understand when that whole madness got started of everybody in the world 3D printing face shields. Why didn't people go for casting them? Was there a reason for not going that route? Was it just more expensive or harder to do, or
it's a bit harder?
Then you could make 100 at a time, right?
Yeah. Like in the end, like the PLA or ABS is maybe like, I would say between 15 and 25 euros the kilo. This stuff is a little bit more expensive, but this also depends on in what quantities you buy the resin. Your first investment is a bit higher because you need to buy the silicone, which can easily cost you a few €100 just for making the first proper mold. But then you make, as I said, you can make, if you use a fast-setting resin, you can make one copy every 5 minutes.
Yeah, instead of it taking hours to print a new one. Yeah. Okay.
I mean, my students in Tunisia, they did the molding at the end, but they made kind of a deal with the industry that they had some income afterwards because it was expensive to develop just the first mold.
Yeah. Yeah, I thought about this, but I don't know, like we never got to making a mold, unfortunately. But this actually would be the right way to do it.
So, by the way, just for your own information, in Cleves, we have an injection molding machine.
Oh, wow. Okay.
I mean, it would never have been able to do industrial stuff, but if ever we want to try in a future Fab Lab or something, there's an injection molding machine here that we can give a go.
Yeah, awesome. Oh, no, I lost my page. Sorry. Okay, so let me just get back to a proper view here. Okay, yeah, injection molding machine. This sounds like model airplanes to me. So you probably all know those type of models where you break them out. There's still there's the sprue somewhere, and then there's the runners and the gates. This is not exactly the same as our resin casting. This is all injection molded, but it's a good idea to orient yourself on those types of models, because you can easily resin cast all of this. The other way around is not true. Like, not every mold that we're going to make is going to be good for injection molding, but if it's good for injection molding, it's also going to be good for the type of molding we do. Okay, so I could go into more how to say, recommendations on what type of model to choose, but I realized, like, the more detailed I go, the less likely it is that people are actually going to use it, because everybody wants to do their own thing. But I guess if I say chess figures, it's general enough for being like, this is a whole field, so you can still be creative in what exactly your chess figure is. But this is also the maximum size I want to end up with. Like, chess figures are already quite big for what we're gonna do. If you guess,
Freddie,
I guess, yeah.
Do we have a group assignment in this week?
I don't think so, no. Or
okay.
It didn't used to be the case. I should double check. Kinderüberraschung, like those Kinder eggs. This is exactly the right size. And
are those illegal to take to the United States? So be careful about that.
Okay.
Sorry, guys.
Yeah.
There is a group assignment, which is, I think, review the data sheets of the material that we're going to use.
Ah, okay.
But you can move far away.
Yeah. But Kinderüberraschung is exactly the size I want to go for. And if you Google for, like, all the stuff they have put in there in the last, like, probably 40 years, there's, like, yeah, there's a wide choice of possibilities in this scale factor. Also, of course, Lego and other action figures, like, or Lego, Playmobil, like all those toys are good size. But for example, Lego is incredibly difficult to make. Like, Lego this is the highest art form of casting. But that's yet another story, because this is injection molding. Then there's these action figures, like if you go to one of those comic stores in the United States, there's a whole department just for action figures. You can buy any movie character in various sizes with highly detailed castings. It's beautiful. Like, if you ever get the chance to see something like this, it's amazing. Then, of course, like the tin soldiers, you know, those little figures that kids play with. This is also a good form factor. And of course, since we're in Germany, we should make some Gartenzwerge, just as a just as a hint. You know what a Gartenzwerg is, William? Ah, you're muted.
Yeah, I know. I used to have one. I'm just looking to see if he's here. Somebody might have stolen my Gartenzwerg.
Oh my God, you're too German already.
Oh yeah. No, I instead of Gartenzwerg, I have a heron. This little guy.
Okay.
But yeah, somebody stole my Gartenzwerg.
No.
The closest I can come is a rabbit. There we go.
Okay. In Spain, they're going crazy for something a bit different, and they call it caganer, which is the same size. And this is like, I'm not sure if it's for Christmas, but it's like any souvenir shop in Barcelona, you can find a caganers of almost anybody, and it's like little figures that take a shit. And you can find them in any shape and size, and Like if you want Angela Merkel taking a shit or Donald Trump, they're all there. So, yeah. Here, Messi, Super Mario Brothers, Lady Gaga. Okay. But actually, before thinking about your model, you should think about what type of mill are you going to use, because this is going to tell you if this can I do this model or not. Depends on what mills you have. And so the typical mills that Neil recommends is this 1/8 or 3 millimeter end mill. This is a 4-flute end mill. And our good old 132, this is 0.8, and this is for the more detailed stuff. But you can already tell like that this won't allow you to make features that are very deep. So anything deeper than like 2 or 3 millimeters is unreachable with this mill. So if you look at, let's say, looking for a feature that is small enough that would give us trouble in this case. Oh yeah, look at the hands of the little guy. Those might be unreachable for us. First of all, because we have I think those hands are made in a separate mold, and then they just stick them together. But they might be, the fingers themselves might be too long for getting in there with a small end mill. So yeah, so the choice of your model kind of limits what you can do. For example, in the pi sign, like this would probably be the most critical point, because the walls are almost vertical, and this is deep down. Same for the, oh, how's this called, the thing from Exterminate? Yeah, never mind. But like this detailed
You
stuff.
mean the TARDIS, you mean?
Yeah. Like those features at the very bottom that are very detailed, this is the tough parts. Like you won't get there with this mill. Or you will get there, but then you will also touch on the side of your mold, or yeah. Like for my gear, I bought this very special mill from the jewelry store. They have special mills just for milling the wax. They're very simple. They're just regular HSS high-speed steel, and they have these special flutes that, because the wax is easy to mill. You just the bigger problem is of how to get it away, because if it accumulates in one spot, it will get warm and then it will melt back into your mold or into your master, and this is not what you want. So if you're using regular mills, you want to choose the minimum number of flutes you can get. Like 1 flute is good, 2 flutes is still okay. 4 flutes, you already run into problems with evacuating the chips. And then there's the big choice between a round end mill and a square end mill. And basically for most parts, the square one is better. You might think, this one is round, so I won't see like the steps between my different passes so much, which is true. But if you make 3D movements with a square mill, those lines also almost disappear. The big disadvantage of the round end mill is that you can't make a flat bottom. Like if your feature has a flat bottom, you need to make very, very many passes with this one. Whereas with this one, if you make stepovers the same distance than the diameter of your tool, you already have a flat base, which with this one is almost not achievable. And I think all the examples that Neil shows, they're all made with a flat end mill.
The little beast you were asking about is the Dalek.
Ah, of course.
Exterminate.
Yeah. Exterminate. Okay. Yeah, and so the next part where where this choice of end mill plays in is the like previewing your mold. So this is from Saverio's page, and this is from my page. So there's it's very easy to get like you have this first step where you do the roughing, where you just try to quickly remove as much material as possible, and then you do the finishing. The big difference between roughing and finishing is that the roughing considers all the material around your model, whereas the finishing only considers like a 0 point something millimeter offset from your final surface. And in most software, the finishing doesn't know about the roughing. So once you get to the finishing, it does not know that you left those bulk materials there. In my case, do you see that there's like a little bright spot where this knob is missing? This is because when I did the roughing, the distance between my registration pin and the wall was too small. So my 3mm end mill didn't make it through there. And then when I started the finishing with my super thin mill, it would just run full speed into this little piece that was still left. Like here, this is the perfect example, yeah? So be aware that any place where your roughing was not, how do you say, did not take enough material, your tiny little finishing end mills will run into this at full speed and break off parts, just like here, or break your whole, or break your end mill. Like so this was Saverio's first step in roughing, and he very nicely explains like that he was so stupid not to do anything about this, but to just continue with the finishing, and then of course he broke his milling bit. And so sometimes and you see that the steps in roughing are quite big here. Like that's like 3-4 millimeters. Sometimes you want to go a bit slower in roughing, like have a step down of maybe just 1 millimeter instead of 3, because then you save time in finishing. Because if your tiny little end mill is trying to mill away all this tough material, you have to go slow. If not, you'll break it. So maybe go a bit more detailed in the roughing, and then you have an easier life for the finishing.
Ferdi, just one question. I think there are software that have adaptive step down.
Yeah.
They can go like chunks at the beginning and then very small at the end.
Yeah. Yeah, this depends on the software you're using. And so, yeah, one very important recommendation is model your mill. Like before you start milling, you should like redesign all the tools that you're using and just stick them into your 3D model. Can you tell what's wrong in this picture?
I can, but I will not.
Anybody?
Well, yes, I guess with a mill like that, you will never be able to carve out the vertical walls here.
Exactly. Yeah. So you there is software where you can define different regions. So you could exclude this. You could exclude the sidewalls for the work that you're doing with this mill. So she actually milled it with this small mill, but she excluded the sidewalls for the operation with this very fine mill. If you angle your sidewalls so that they're like chamfered, just like here, then you wouldn't have to care about this so much.
And it's also easier to get the thing out of the mold too if you do that, isn't it?
Yeah, this is not getting the silicone out is almost always quite easy.
Oh yeah, okay. Even with a vertical side like that.
Yeah.
Okay.
It's more for the milling than for the taking it out.
Okay.
And yeah, here you see this white circle. This is my 3mm end mill, and I'm looking if I can pass between my part and the registration pins. And in this case, I go all the way around my registration pin because I also need space here and space here. If not, you will get into problems for the finishing. Then it's another important step is to simplify your model. Like if you can, like this one is like a bomb. This is one of Saverio's models. I think he shows it in the very beginning. No, he doesn't. It's in the other PDF. Just a sec. Yeah, so he wanted to make this, and he just took it apart. Of course, he had to like, this is an extra, which didn't exist before, because it was just same part than this one. So he decided to make this one hollow, and then extend this one so that it has a part where you can stick the wings on. And yeah, so this is an important step. So you simplify your pieces. You can make, you can't do undercuts with milling, but you can assemble several pieces into one. So this is the student with the nose, and she milled like the top of the nose and the tip of the nose in two pieces, and then she glued them together. Can you tell that this is one piece and this is the other? So that's a cheap trick for making undercuts. You just make two models and then glue them together. And this is actually something I would encourage you to do more, because the silicone, you can demold even quite big undercuts. That's not a big problem. And you can also easily get your pieces out. So if you run into something where you're like, oh, I would like to have something with undercuts, just make several pieces. Another topic is how do I align my two parts to one another? You saw that like my first try with those little cylinders failed miserably. Like they're not easy to fabricate, and yeah, I wouldn't recommend cylindrical pins. They also don't self-align. You have to like really get it together in the right way. I would also, if you do something similar to those, I would recommend you to do them asymmetric so that you can only fit them together in one direction. For example, this sardine mold that I made, you can see that there's a border going all the way around it and the negative of this on the other side. This works very nicely, but if I would do it again, I would make it asymmetric in some way so that you can only put it together in the right orientation. If not, you might end up with your tail on in the face of the other half. This is another example of something that works very nicely. So he made a border that goes all the way around. And yeah, so in this case, even if the flushing starts like leaking a little bit, which it always will, you're never going to put two parts together and not have any liquid go in there. But at least you want it not to run empty completely. So this second border here is just like, in case something really goes wrong, you still have like a double floor. Okay, and this is the part where I still haven't finished my preparation. So I made 2 videos explaining the whole process of, let me see, like this is molding casting 1. I should still like cut out some parts, like the videos are just still my rough, how do you say, this is just the way I did it from beginning to end. So first I was Googling for a Lego piece, just as an example of something that I think is the right size. And so you can see me looking for reference pictures, and I took this one, and you can just drag and drop it into Blender, and then you can orient the plane so that you have a front view and a side view. And then I just started what people call box modeling. So you make a box and you start shaping it until you get something that resembles your Lego piece. And right here I'm using Blender, but you can use any 3D modeling software that you want for making your model. What's important is that in the end we want to have one solid piece. So if you watch this video, you can see me using the Boolean functions a lot, which allow me to make cuts. Like here I'm just placing this one and then subtract the cube from the cylinder. And in the end, I use the Booleans for joining everything, so that I have one solid instead of like several. I'll just go quickly through this. So this is me putting a lot of effort into making the seam of between the legs, which don't show up in my final model because this is too small of a feature for being visible with a 3mm end mill. So this again, your choice of tools will limit what you can model and whatnot. So yeah, if you want to get this assignment done quickly, you should mill everything with a 3mm end mill, and so don't choose a model which has a lot of detail. For example, with a 3mm end mill, I won't get into the hands. So this would require an extra step in machining. And so I just skip ahead a little bit more. I think that's almost it. Yeah, so this here is my Lego model. And here you can see me like going Boolean the arms to the body, and then the hands to the rest. So it's Boolean union, and then you pick the arms or the hands, you apply, you delete the hands, and you're left with one mesh that is the whole figure. And that's end of part 1. At part 2 is how to make the how to make the rest. Or is it still in part 2? Oh yeah, okay. So here, first thing I'm doing is I just place my model in the middle, and I make a piece. I model the piece of wax. So this has the dimensions of my piece of wax. You can find the dimensions of the wax in the presentation. I think I put them somewhere very much in the beginning. So it's 20 by 7 by 4 centimeters. Maybe we should double check. Maybe William, if you realize that the piece of wax that you have is different in size, let us know, because this will limit what we can do and whatnot. Of course, you can always glue several pieces together, but it's good to know what the size of your wax is. And here I also realized, whoops, something's wrong with the dimensions of my little Lego piece. So I realized that I was mixing up the Y and the Z dimension. So I scaled it to the right size, and then ta-da, suddenly it's small enough for fitting into my wax.
I've got some fancy dimensions. Mine calls itself 3 5/8 by 6 by 1.5. But that's the size of it is about what you described.
Ah, okay, perfect. Then you can see me modeling my mill. So this is just like 3 millimeters. And in this case, I didn't worry much about the length of it, but we'll get to this in a second. And then you see me just making a plane. And then I'm already going around with my end mill. Oh, here I'm already cutting my piece into 2 halves. And this is an important step, defining your parting plane. Like for for more complicated molds, this can get a science. If you look at injection molded pieces, like the decision of where to put the parting line is a tough one. But yeah, in this case, it's quite easy. I just cut it in the middle. And then I make my box with the chamfered sides. The angle and stuff is not so important. I would rather open it a bit more than a bit less. Again, it depends on the mill that you're going to use in the end. But then in a second, you will see me going around a lot. You see, like if I have it running. So, okay, this is my little registration pin. And I'm like, oh, do I get through there? Yes, okay. Then can make a copy of this one, put it somewhere over there. And I'm placing it asymmetrically on purpose. Like this is just for making sure that you don't close it in a way that you don't want. And again, checking, do I fit through there? No, damn it. So it goes further to the left. Check again. Oh, yeah, this is close. I think in the end, I have to make the box bigger because I can't fit the pins in there. You see? So yeah, so this might change everything. Like simple stuff like this might give you more trouble than you think. But that's normal. Okay, and so once I have my two halves, I place one on top and one on bottom, and then I flip one of them. And then I have my two halves made. And just for the beauty of it, I model the little box around it, which is actually not necessary. Like just this would have been enough. But yeah, I make it the box. And that's all you need. I know. Of course, on one side you have to cut the registration pins, and on the other side you have to add them to the model. So here you see me Boolean, Boolean, Boolean. If you don't do all this Boolean stuff, it's like in 3D printing. If you give your CAM software a choice between seeing this as positive or negative, it will mostly go wrong. So if you want to be safe, just make everything one mesh.
Ferdi, a small question about the registration pins.
Yeah.
Here. Are we going to use, you think, such finer hand mill that we can make these holes as round shape here for the rough cut? Or you're going to make them in the finish cut?
This is in both. Like in the rough cut, it's just going to make coarsely rough it out, and then in the finish, you would actually go through. And this wouldn't even take longer than making something less detailed, because your finishing is just going lines, and it's not going to be a lot slower if you...
Yeah, I was just thinking that the finishing for me doesn't touch the registration pins. So I do them with the roughing, and then the finishing will just do the details on the piece. But that's another thing.
Yeah. Yeah, actually, that's a good idea. Yeah. So if you find ways of saving time in milling, go for it. Yeah, maybe for the Lego figure, like just making a border all around, like a picture frame on one side, and then subtracting the picture frame on the other side. This will be enough. Okay, so this is just taka 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 taka, and so for the choice of software, like for making your model, you can use any 3D software you want. Like I used Blender, but Rhino's fine, Moi, Fusion, OpenSCAD, Tinkercad, FreeCAD, SolidWorks. This is all good. Give me 1 second. Omid is calling me from the Fab Lab. Hey, Omid. Hallo, hallo? Omid? Now he can't hear me. Omer? Okay. Yeah, he's probably standing in front of the Fab Lab and trying to get in. Yeah. Omer? Hörst du mich? Hi, grüß dich. Stehst du vom Fab Lab? Ah, okay. Ja, ich komme gleich. Wir haben noch Vorlesungen gerade für FabAcademy, aber so wie ich fertig bin, komme ich rüber. Ah, okay, super. Bis gleich. Tschüss. Okay, sorry. Yeah, so it doesn't really matter if you're working with a mesh model or with NURBS. It makes a lot of stuff in the CAM process easier if you model with surfaces or with a NURBS model. But as you saw, me using Blender, this also works. Like this depends on your on which program you fancy. But for example, working in SolidWorks allows you to use the mold making tools in SolidWorks, which makes a lot of stuff easier for how to find your separation lines and all of this. SolidWorks has a special module just for like this line of separation, where I cut my model in the middle. SolidWorks has its own functions just for finding this line. And if you look at more complicated injection molded parts, you will see that this can be quite tough sometimes. But since my recommendation for this week is to make a single-sided mold, this is probably not going to be your problem. And there's a lot of more problems that can go wrong. So I would recommend you to concentrate on something very simple in the first place. And then if you want to make something more complicated, like two-sided molds, maybe do this in the next week. Because we have this, how's it called? Like this 1 week where you can do whatever you want. Yeah.
The wild card week.
The wild card week, yeah. Okay. And so if you want to go the open source way, I would recommend you to use Fab modules for making your G-code. We also have Modella Player or SRM Player installed on one computer in the Fab Lab. You can download the software for free, but you can't install it if you don't have the machine connected. So it wants it wants to see the machine. It wants to see that you bought the machine before you can use the software. I don't know if there's any workaround on this. Maybe Daniele knows, but yeah. Of course, RhinoCam would also be nice if you have a license. If you don't, then RhinoCam is going to be difficult. Fusion and the Fusion fabrication part, that's a very good team. Like I would highly recommend you to use Fusion if you can. But you could also use, let's say, OpenSCAD and mods. So mods is very similar to Fab modules, but I personally haven't used it yet for mold making. And Neil kind of mentioned that it's partially experimental, which it turns on all my red lights. So like, if you're really brave, try mods. But if you want to have an easier time, just take Fab modules. And FreeCAD also has the path module, but I'm not sure if it's completely set up for 3D milling yet. You can definitely do like the 2.5D milling that we're doing for us, make something big, but I'm not sure if it can do the 3D milling. And yeah, and as I said, like SolidWorks has its own workbench for mold making. So if you can do this combination, this also makes your life a lot easier. And maybe let's have a quick look at what this would look like if I do the Fab modules. So you can see me here exporting my models. And so now I have two STLs, one for top, one for bottom. Then I went to import STL, and you get something like this. You have to make sure that this scale corresponds to the scale that you actually have. And so you have to put 25.4 for converting from inches to millimeters, and double check if this is the dimension that you originally planned for. And then you calculate a height map. And at this point, I should have realized that something's wrong. Can you tell what it is? Like if something just has one color, it means it's flat. So something's wrong with my head and with the feet. But I only realized this a lot later. There's presets for foam rough cut and foam finish cut, and those perfectly work for the wax as well. So in Fab modules, if you just use the presets, you're probably going to be fine. But another recommendation is to use a low resolution in the beginning. This will make the calculating your tool paths a lot faster in the beginning. And here you can tell that I'm somehow not very happy with the result. But I only realized what's wrong exactly once I made the finishing. So here you can tell, whoops, why is my head square? So I went back to Blender, had a look. Whoops, no, my head is round. Why does it appear square? And the solution is the normals. Like I hope you don't run into this problem, but I just had to go into Blender and say unify normals. Took me a while to figure this out, but here you see me mesh. Where is it? First I tried to triangulate everything, still didn't work. Still everything just one color. And then I went back and finally figured out, here, recalculate normals and export everything again. And suddenly my head was colorful and I would get a nice finishing cut. Yeah, so this is very simple. Oh, this is another point, like the depth. Like here you can see me measuring the depth of my model. This is important in several aspects. One is like you have to have an end mill that is long enough for reaching all the way to the bottom. So you want this to be shallow, but on the other hand, your silicone, when you degas it with a vacuum, it will rise. So you want this as deep as possible. So yeah, on one hand you want it very deep for degassing, and on the other hand you want it very shallow for not having a stick out of your tool that is very long. Yeah, so let's get back to the presentation. Here you see me very naively calculating my space. So I tried to use this one block of wax for making one part for my colleague at FabLab and one for myself. And I wanted to make 4 different models just from half the block of wax. In the end, I made one. Even though I very carefully cut my wax into pieces, did I realize too late that that I don't leave any space for the silicone to grow. So I had to make another box around my wax, which is perfectly feasible, but just something to think about in the first place. Fixing the wax in the machine, like Neil shows this one here with the hot glue. Not so sure about this one. This is definitely the most solid way you can do it. Just screw a piece of wood all around it. Or if you can put a vise inside your machine, this is also a good solution. And then you have mostly, you will have just the roughing and the finishing. But in my case, I had an intermediate step because with a very fine end mill, it would have taken ages to do this intermediate step. So I used like a 3mm mill then like a 2 millimeter mill, and then the 0.5 millimeter mill, just for making the fine teeth. And what of course will happen, or might happen to you, this is Saverio's page, and you remember that he broke his mill in this corner, and of course once you hit the emergency stop, the machine doesn't know where your 0 was. So if you find a way of remembering your 0, do it. Like what I ended up doing most of the time is just while setting my 0 point, I would just leave a little mark on my wax. So I have a little dent where I can go back to. If I really lose everything, I can still try to fit the mill into the same hole. But since your 0 point is mostly determined by your 3D model, you can also just go in one corner, leave the little mark, and then remember to go, let's say, 5 millimeters to the right and 5 millimeters to the front, and then set your 0. So this way you can always find back to your 0. But since our machines, or most of our machines, have end stops, you can just home your machine in the beginning and then write down the machine coordinates of your 0 point on a piece of paper or in a document. Write them down. If you just took a screenshot but didn't save it, it won't help you. So either write them, if your machine has limit switches, you can write down the coordinates of your 0 point. If not, leave a little dent in your mold so you can find back to it later. Then once your mold is finished, you want to determine the volume that you need in resin for casting. The resin is expensive, so we don't want to waste it. One way of measuring it is like using, in this case, it's like the pellets from injection molding. But you can also use rice or little pasta. I bought some grains, like anything that pours well and doesn't leave dust or dirt behind should be fine. And then you can measure the volume it has. This is going to be one of the very few times where we measure the volume instead of the weight. Normally we do everything by weight, but in this case, you can, like if you pour water in, which would be the most accurate, then you could pour the water back out and measure the weight. And by knowing the density of your resin, you could calculate what the weight of your resin would be to fill it the same way that the water does. But if you do it with water, you have the problem that afterwards your mold is wet. And if you pour in silicone, it doesn't like any wetness. So you will have to like dry your mold first, which is going to take time. And if there's any drop of water hiding in some undercut, you get a problem. So using something pourable and going by volume is a good idea.
Freddy, just to mention, there is also the simulation that can help you in determining the volume.
Yeah, of course. Yeah, this is obviously the most sophisticated way of doing it. You just like you can just Boolean out your model from your mold and then measure its volume. Like you can do this in Blender. It's probably even easier in SolidWorks or in Fusion. Yeah, this is probably a good idea. But just a quick workaround would be to measure the volume of something that you can just pour in. And you always want to, like, if this is the upper side of your mold, you want to have at least like 5 millimeters material on top of it, because if not, your mold might get too unstable. It will just be wobbly and you won't get the right resolution. Then mixing. So in the FabLab, we have these very fancy mixing cups. And I don't know how much they cost, but this is awesome. Like And you want your mixing container to be very solid. Like if you have something that just like if you take yogurt cups, which I think it's a nice idea to recycle yogurt cups, but they're not stable enough. Like the top part might crack, and then suddenly during mixing, your mixing pot falls apart. And nightmare. You will lose all your silicone, and in the end, the environmental harm that you did by losing all the silicone is much bigger than the good you did by recycling some old containers. What also works really well is those ice cream containers, because they're very solid. They don't break. So never throw away your. If you go to the Chinese and buy some takeaway, don't throw away the containers. They're good for mixing resins. And being transparent is also a big advantage. Like if you have a lot of experience, you might be able to go with a non-transparent one. But in the beginning, it's very nice that you can see if your two components are mixed well. And mostly they will stick on your container. And so if your one part is blue and the other one is white, you see through the transparent container that the wall is still white, then you know, okay, I still have to mix this part. Once you have some experience, you know that you always have to keep scraping the walls for ages. But in the beginning, I would really recommend to use something transparent. This is how I started. This was before realizing that those are not, it does work, but I wouldn't recommend those plastic cups. You need something that is, that you can, where you can be more aggressive without breaking it. You see that I cut off the top, because if not, it wouldn't fit into my vacuum chamber. So this is another consideration. But since in FabLab we have a huge vacuum chamber, this is not going to be a problem. And you see me here with a third cup in the middle. So if you're very concerned about not properly mixing your two liquids, instead of pouring one into the other and then mixing it in there, you can just pour both into a third container, which makes sure that you have no leftovers at the walls from one or the other. So almost everybody ends up not mixing their silicone well enough. I think Neil's recommendation normally is mix it until you're perfectly sure that now it's completely mixed, and then mix for another 2 minutes. And this is very true. Like, you want to be really, really sure that both of your components are very, very well mixed, and that there's nothing sticking at the walls, nothing sticking at the tool that you use for mixing them. I highly recommend chopsticks. Haven't found anything better so far. Don't use those. Those are too thin. You can't use, like, if it breaks off while you're mixing, you lose a minute and your silicone will start setting. So for the mixing, on one hand, you want to be super fast so that you have more time for pouring before your silicone starts to get like gel-like and it doesn't flow anymore. On the other hand, you want to spend as much time mixing as possible, because you want them to be well mixed. Because if you pour them into your master and it wasn't mixed properly, it won't harden, and then you destroyed your master, because trying to get some sticky, uncured silicone out of your master is almost impossible. It's probably quicker to make a new master than trying to clean it from uncured resin. So yeah, this is actually the worst thing you can do, not properly mixing your silicone. And unfortunately, this happens to almost everybody. So it's one of those things that I guess you just have to do it wrong once, and then you will probably never do it wrong again, because uncured resin is just a horrible mess. Then the pouring itself is another science. Don't do it like this. Like this guy is doing everything wrong that you can possibly do wrong. I can see the bubbles growing in here. Like each of those folds is yet another bubble that you get. It's also not recommended to pour it like perpendicular to your flat surfaces, because the resin falling over this gap will also trap air at the corners, and there's almost nothing you can do against it. Neil recommends to hold your mold at an angle so that it never hits like perpendicular to a flat surface, but always at an angle. Yeah, it's easy to say and hard to do. Some people actually leave a special pouring area on one side that they make flat, so that you have one specific area where you start pouring. You never pour in the middle of your model. You always pour on one side, and you also don't pour all the way over. Like if you start pouring at one spot, you continue pouring at this very place. Don't try to like pour all over. In Saverio's examples, he mostly starts by just brushing all surfaces with a brush. This is necessary if you don't have a vacuum chamber. In our case, we can just use the vacuum for getting rid of those bubbles. But some people actually, they mix one batch of silicone first, then a small batch. With this one, they brush all the surfaces, and then they make another batch, because then you take out this time pressure that you have. You make another batch, and then you pour the rest. There's one theory that like if you pour it in a way that it makes this very thin streak, that the bubbles will burst while falling down, because this is too thin for the air bubble to stay in there. I think this is a myth, but yeah, I tried it with different methods. You can also you can do a dry run, just pouring the unmixed silicone to see which pouring technique gives you less bubbles. But since we have the vacuum chamber, this is not going to be our main problem. But if you don't have a vacuum chamber, the way you pour is very important. You can also see, like this is Saverio, and he had his silicone in a big bucket or in a bottle, and since it's not very easy to precisely pour out of a bottle like this, also without making a mess on the bottle, he just uses an extra container just for pouring. If not, something like this will happen. Can you see this is going to be a mess, and you want to keep all your containers clean. So please, after using, especially if you use big buckets like this, you don't want it to look like this afterwards, for many reasons. And one problem that, yeah, we're most probably going to run into is bubbles. This was my first cast and looked horrible. I think this is one of Neil's models. Like, yeah, we're always going to have bubble problems, but our big vacuum chamber is going to make this a lot easier. Yeah, here you see different models of vacuum chambers. This is the one that I built myself just quickly for getting stuff done. This is the vacuum pump from the laser. You can buy ready-made vacuum chambers like this one or like this one. This one is also an easy solution. You just get a big thick sheet of acrylic and connect your vacuum pump, and then you can use any cooking pot or anything that won't implode on you as a vacuum chamber. And I think I put this video for a good reason, because your silicone will rise when you pull the vacuum. So here you see that in the beginning. Oh, right. Reload page. You're still all there, no? Okay. Oh yeah. So this is in the beginning, the liquid level is quite low. And now have a look on how this expands with pulling the vacuum. Like all the air bubbles will increase in size because there's less environmental air pressure on it, and it easily doubles in volume. So if your mixing cup is not big enough, yeah, so he already reaches the point where he has to release the pressure. If not, it will just flow all over. And so, yeah, in this case, he repeats it like 3 or 4 times. But yeah, so when you're designing your mold, bear in mind that it will increase. And here you can see this is already the point that you want to reach. So now it's not increasing anymore. It's just bubbling. Almost looks like boiling. And actually, if you have water in there and you pull a very high vacuum, it might actually be boiling at room temperature. So yeah, that's another problem that you run into when you're using something like gelatin and glycerine, that at the low pressures, your material might start boiling, which is not what you want. Okay, so I lost my place again. Okay.
Fadi?
Yeah?
For how long would I have to do this degassing? How much time does that take?
This, if everything goes well, this should be done after like a few minutes. Depends on how. Yeah, I didn't talk about the mixing part. So also the way you stir your resin is important. So Neil always says shearing, not what does he say? Like he wants you to move your. Can you see my camera view also? Yeah. So he wants you to stir like this, and not to move up and down, because once you move like this, you're pulling air into your resin, and this is what you want to avoid. But of course, on the other hand, if you had 2 layers, component A, component B, without any up and down, if you just move it like this, they will never mix. But if you incline it and move it, and like it's easy to say don't move up and down. At some point you kind of have to, but yeah, just be careful trying not to pull too much air into your resin.
Do you degas before you put it in the mold, or do you degas once you've poured it into the mold?
Both.
So you do it twice?
Yeah. So normally after mixing, I degas my silicone. Then I pour it into the mold, and then I degas my mold.
So how much working time do you have typically in the silicone?
Maybe like we have to look at the data sheet, but this is like the pot life that you have, and this is usually between like 5 and 20 minutes.
Is that the working time?
Yeah. It's always not enough. So
yeah, it sounds it.
Once you mix your 2 components, it's you're in a hurry, and you want to prepare everything that you might possibly need beforehand. So
well, it's the same with plaster. Yeah. Do you have in the vacuum chamber? Is there a mixer because ours in England used to have a mixer paddle in the vacuum chamber specifically for this purpose? Does that?
Yeah, our vacuum chamber has a mixer inside. I've never used it, but yeah, I would just go and mix it beforehand and then put it inside.
And then put it in there. Okay.
But yeah.
Presumably, when you degas, the bubbles are going to create some more mixing, aren't they?
Yeah.
Okay.
So once you get to this point, you want to have everything prepared. You want to have your surface on the table for not making a mess. You want to have your chopsticks ready for mixing. You want to have your mold ready for casting. You want to have some toilet paper or some kitchen towel around for cleaning, which you will definitely need. You want to make sure that you wear the right clothes for not making a mess. You want to have everything you need for documentation ready. You might want to have your computer for writing down the volume of how many grams of silicone you used. You want to write down what you identified to be the volume that you need. You want to have your camera ready. You also want to think about like, how can I make photos of something sticky while not messing up my camera. Maybe you have another person that takes the photos for you, so you can concentrate purely on the mixing, stirring, and pouring part. Like from here on, you want to plan everything up to the finished pour, and not have any, like, you don't want to realize in the middle that you actually need some paper towels, because every second that you're not busy preparing this is time that you're going to lose, and probably your mold will start setting somewhere in the middle, and you're going to lose all the work that you put in there so far. So this is really the part where you have to plan ahead. Talking about the vacuum chamber, there's two philosophies. One is like you pull a vacuum so that all the bubbles rise. The other one is you put it into a pressure pot and you increase the pressure so much that all your bubbles get very small. I highly recommend this video. It makes a comparison. This one is more for the casting resin than for the silicone, but I think for the silicone, the vacuum chamber is a good choice. But once we get to the resins, it might be a better idea to pressurize your resin instead of degassing it with a vacuum. And here's another picture of something, like you have to pre-plan that your silicone inflates. So if your mold is not deep enough, it will like rise so much that it goes all over the place, and then once you release the pressure, it's not going to be completely filled. A cheap workaround is to just make a little paper wall around it, or to make a wooden box around the whole mold. But if you can, and if your wax is big enough, consider that your silicone is going to expand in volume when you're degassing. And this is another technique. You can see him just painting the shape with silicone. And in the next step, he's going to pour gypsum into the rest, just for saving money on the silicone. Okay, and so once you poured your stuff and you degassed it, you want to put it on a table that is level. Like this was the problem in Barcelona, for example, all the tables were completely crooked. So you would place your mold onto a table, and next day you realize it's like at a 20-degree angle. Like already when you're in this position, think about like, where do I put everything once I'm finished? Because you don't want to put it on a table that is not flat, and you don't want to put it somewhere where somebody else is going to cut wood right next to it, and it's going to be full of wood chips on the next day. You also don't want to move it for a while. The higher the temperature is in the place where you cure your silicone, the faster it's going to get. Like this umu stuff normally takes 24 hours, but if you put it at 60 degrees, you might be able to use it after 2 hours. And this is similar with most of the silicones. Then another interesting question is like, how do I, like many times, especially with like two-part molds, the silicone doesn't get everywhere you want it to get to. So you could think of a technique like this one, where you have your silicone on one side, and then you integrate into your master an entry and an exit port where you can connect hydraulic or pneumatic hose, and then you have a chamber which is just a trap. So if any silicone makes it all the way through here, you have it mess up this jar instead of your pump. Then you pull a vacuum on one side, and the vacuum will pull the resin all the way through your mold into the trap. Here you can see like a detail view. You could also have this just with a funnel and a pipe fitting, a pneumatic fitting on one side, and then you pull vacuum here and suck in the resin from there. You can see that here it goes all the way around and fills the mold from bottom to top. Yeah, this is a bigger effort, but it might save you time in the end. Here you can see the setup with the trap and the pump. And this is not necessary, but it's like depending, like if you try to cast something as tiny as this rubber ring, then you might need it. For a simple one-sided mold, this won't be necessary. Yeah, could anything possibly go wrong? Yes, and it will. The worst one is like unhardened silicone, because it destroys your master and you have to start from the beginning. Unhardened resin will destroy your mold, which is not so bad because you can remake your mold if your master is still fine. Then you can also get all kinds of funny chemical reactions. For example, if you use the wrong mold release and it reacts with your silicone or with your resin, you suddenly might have bubbles, or it might stop curing. Or maybe you thought it's a good idea to fix a hole with some plastilene, or what do you call this? It's like, is it called plasticine? Knete? Do a test before if it reacts with your silicone or with your resin.
Yeah, plasticine is what you... There's a number of different products there that are called plasticine, but yeah, Knete is a different kind of thing from plasticine. That's called clay.
Okay, yeah, some of them might have a reaction with your silicone or with your pouring with your resin. So you should make a little test before, like whatever you use that is not the wax, make a test. Another common problem with like two-part molds is that your mold is not watertight. So after all of this work, like if I see this, I know this was not the first try, you know, like all this tape around, because probably on the first try, he did it like this with some double-sided tape, which is a really bad idea. So probably, I don't know, in this case it went well, but like just like this, probably your like wax on wax is not watertight. So probably in this case, the whole thing drained on the bottom. And yeah, you don't want to come back to your mold realizing that all your resin left through a hole in the bottom. Yeah, so leaking molds is very common, and then it's also quite common that your mold or master didn't fill completely. Yeah, so you suddenly have like air bubbles inside. One way of getting rid of this is the place where you start pouring. If you give this one a little bit more volume, you can make sure that that there's a little reserve, that even if you're if you poured and it's filled up to here, but there's a big air bubble, and now you start moving it, and the air suddenly escapes. You want some extra deposit of material to take up this place then. Also, yeah, so in this case, the place where he poured in was just a hole in the silicone, and there's no way this is gonna stay without an air bubble. You want the part where you pour in, you want to be generous and have some extra volume so you don't end up with a hole in your piece. This was an example for what happens if there's something reacting with your release agent. So in this case, it was just making a lot of bubbles, so my final cast was like styrofoam. I could just break it with 2 fingers. And this is the example for what happens if you didn't put the right release agent. It will just stick to your final cast, and you have to throw away your mold, and your final cast is probably also unusable. Looking at the part from one of Neil's students, like the Fab Remote, you can tell that he went through quite some iterations until he ended up with a usable mold. So yeah, it's something's gonna go wrong for sure. Here you can see what happens if your silicone starts curing halfway through. So suddenly you can't pour it anymore, but it turns into like this sticky paste that wants to stick to everything but to your mold. So yeah, be fast, so it looks like this and not like this.
Maybe one small thing to mention that happened to me is that when you mix some resins, they become very hot as reaction.
Yeah.
Sometimes they can even melt the mixer or the, and then you have something.
Oh yeah, another thing to bear in mind in this respect, like if you have your volume of like this will get very hot, yeah. So Daniela is right. Like this is not just a bad idea because it might just rip, but it might also burn your fingers when you're trying to mix it. So you want something like a little bit thicker walled. And the next problem is like if you think like this stuff is expensive, so I just do a test with like a very small amount just for testing if it's going to work or not. If the 2 amounts you're mixing are too small, it will not react. Like it needs some of this heat for starting the reaction. So there's like a minimum amount under which it's not going to work. So if you want to make a small test, I would recommend you to use at least like 20 grams of each. If not, the reaction is not going to start. And if you want to delay your cure, the more you spread it out flat, the longer it's going to take for curing. And the more compact your volume is, the faster it's going to start curing. And yeah, I think that's mostly it. Everything goes well. It looks somewhat like this. I have some more examples of successful models. And even something as simple as this one. This one is just a tiny little mold for making a tile. But since you can make many, many copies, like this you can probably do in an hour. It's like a very simple mold, and the result is beautiful. So don't overcomplicate it in the beginning. Just make a one-sided mold and give it a try. If you realize that this is something you like, you can go more complicated. Yeah, I did this sardine mold, and together with the other piece, all in the same week, and this was taking too much time. Since I didn't have wax in the right size for the sardine, I made my own wax, and this is maybe a bit. I would rather go for something like this than for something like this.
Fadi, I do have one or two questions about how to proceed now. So, if I understood right, the idea is now that we basically create a 3D positive model in Fusion. I mean, I really don't see that I can dig myself into any other CAD software. I mean, I'm busy enough to manage Fusion. So I do my 3D modeling. Then I model the box or the the machine wax package around it and try to see how that fits. Then once I have this this entire piece readily designed, I have to export that into mods to create.
If you're working in Fusion, I would recommend you to do the G code also in Fusion.
Okay, so I produce my G code in Fusion, and then I put the G code on a flash drive and bring it to the CNC mill. Is that correct?
Yeah. Uh-huh.
And the machine will know what to do.
Yeah.
And is it two G codes that I will produce, one for the roughing, one for the finishing? Exactly. Or is it all in one?
One for the roughing, one for the finishing, because you have to change your tool in between. Mm-hmm. I would highly recommend you to choose a model where everything is millable with just a 3mm mill. Then you can do it all in one. Then you don't even have to change the tool.
Yeah, when it's a really small piece, I suppose. Mm-hmm.
Yeah, okay. It's small in size, but big in feature size. Like you want something where you can reach all the spots with a 3mm end mill. Like
okay, yeah. I have one more question. I was thinking to do the molding and casting to produce a little coverage encasing for my moisture sensor.
Uh-huh.
And how would that work? I mean, if you look at that, it's well, it has the plug up here, and it has to be well, it has to expose the surface from below there, more or less.
Yeah.
So it would be a narrow strip about there where I put my fingers, where I would have to, I would want the resin to cover the electronics part, so I can just dig it all the way into the soil and not care about water to affect the electronics, the electronics part. Mm-hmm. Is that compatible? Does that work with the techniques that you described, or is that entirely different story?
No, this would perfectly work. Like I think one of the examples I showed was this. Let me see. I have to share my screen again. Oh no, it's further down. For example, this one here. This was an enclosure for the Fab ISP, and you can see that it's a two-sided mold. This protects the USB part, and the rest it also secures the PCB in the middle of the mold. And then he just poured the resin, and he completely encapsulated his Fab ISP with plastic, apart from the parts that he does not want, which would probably be the easiest solution, but then you will never be able to maintenance your PCB anymore. But it's definitely going to be watertight and waterproof for the rest of its life.
We We used to do exactly that when we were making tags to put on whales.
Okay.
So they have to go underwater. And then what we did, so we would use, we made ours a standard size for cassette boxes. So we used to use the cassette box as a standard size for pouring the mold into. And then for the USB ports, we didn't use USB. Instead, we used just like, the Mac has that magnetic connector.
Yeah.
So we had a similar thing to that, where we would just leave a block of typically a bit of wax or something in the port. So you sort of lay that over the port, then pour the epoxy into the cassette box to then set the whole circuit board in epoxy, including that little piece of wax. And then when it was done, once it was set, we'd put it in the oven at 70 degrees and let the wax drip away. And then we'd have that little port, a little opening on the side where we could get at the access port.
Yeah. And
it wasn't as delicate as a USB port, right? It was just 3 little pins that you would connect your magnetic pieces to. And then what we do is then to put it on the whale, you'd program it, take your programmer off that serial port, and then hot glue over the serial port element. And the hot glue sticks superbly well to the silicon, to the epoxy. And we could send that thing down to hundreds of meters on a whale, and it wouldn't care, because the hot glue seal on that port was just a tiny little port, maybe 4 millimeters by 2 millimeters, where we could then get at it. A little later, what the guy did was take that seal that he'd made with the hot glue when he wanted to send it deeper, because eventually the hot glue does break. For going for really deep, what he would do is fill that space again with epoxy, but with a 5-minute epoxy.
Yeah.
So it has a slightly different stiffness, and so therefore he could see it.
Yeah.
And then when he got the tag back and wanted to get at the access port, he would just take a Dremel tool and grind out the epoxy where the port was. Just grind that off again. You could mill it back off again so that you could get the port connector back in.
Yeah.
So you can always grind away. And then for maintaining the chip, what the guys we deal with in Iceland do for making these little tags that you put on fish and things that are designed to go down to 600 meters, what you do there is you just put it back in the mill. You grind off. They've deliberately made a space. So, Kai, when you're thinking about your device, if you ever need to change the battery, what you do is you just bring your thing out, put it in the vise. You know exactly where the battery is in your mold. So you stick it back into your kind of mold holder, and then you cut between the battery and the circuit board. You just put either a mill or a bandsaw or a hacksaw through there, and then you can then just cut off the bit where your battery is, throw that away, put a new battery on, and just put the new cast on the end so that you can have a new battery connected to it. So they just cut the battery off the end of their tag, stick a new battery on, and recast that part. Or if you need to change a chip, if you've done it if you know where everything is, you can set it up on your mill down into the epoxy, find the chip, destroy it, put a new chip on, and then fill your mold back again. So we've played around with, the nice thing about these epoxies is that a new epoxy sticks to old epoxy beautifully. And so you can then recast to make everything super watertight. If you want to make your device like that. It was, I only ever watched. I never got a chance to do it myself, but that was the technique the guy used, and the whole hard part of it he had with it was getting the air bubbles out, and that really was always the problem when you're mixing epoxy to use as the casting agent.
William, there was some empty spot inside this casting, or was completely filled in with epoxy?
He would fill it completely because it was going to 600 meters, right? So he didn't want to have any air in it. When he did have to make some tags, some of the big professional robot makers, the underwater robot makers, they don't care. They don't bother trying to make waterproof containers or anything else. They just do exactly that. They just fill it with epoxy. And then any air bubbles that are required to keep something mobile or a connector that needs to be kept like that, they use a sacrificial piece, a bit of wax or something at a different temperature, And just like in the 3D printers, remember the old 3D printers that used to have different materials for the support material? And then what you would do, or even that 16 mu printer you guys have, once you print with the extra wax and then you put it in the oven, and that low melting point wax then just flows away. That's how you can go about making those parts. But yeah, with the other piece, that was also important was heat sinks. So you then put the heat sink in your mold, but you bring it up right to the edge of where you're filling. So then you would pour in your epoxy all around and let the heat sink be on the surface, right at the level of where you've poured to, and you had to give it a bit of thickness so that it would have the epoxy would have something to hold to. But then you could actually put the heat sink on the surface or antennas. You put the antenna right on the outside of the mold where it can be done, and then finally, in the end, when things got modern and we got a little more money, they started using inductors and Bluetooth for connections and charging and that sort of stuff. But initially, with the really simple things like the kind of stuff you're talking about, Kai, it was really easy to do, and then you didn't worry about the maintenance. As long as it was relatively see-through and you could see where the line was between your circuit board and whatever it was that was sacrificial, you would then just mill in there, take out your part, and then put a new one in or cast a new one on.
Yeah, I mean, I was still wondering. I mean, I want only the lower part of this to be protected from moisture, right? So I would you recommend that I create a mold that would just fill in, allow me to fill up to a certain level, and then just dip the moisture sensor in it, but then again, I would have to have a second outlet to allow the cable to leave my cast, right?
But Kai, think about the sensing part of your sensor. That needs to be out, I think.
Yeah, that's why. Right, this is the sensing part. So I would leave the sensing part outside the resin. That's what I said. I would just dip this part here into the mold, right?
That'll work fine, except what you would do there is just accept that you're going to have your cable attached to it, that it's never going to come undone. And so then just put the cable in there, take all the plastic off the surface of your cable so that it's just the wires and the shield, and then mold the epoxy right down onto the wires, because what you're going to have is moisture is going to come up along the wires, along the cable. The epoxy doesn't stick well to the plastic coating, the vinyl plastic coating. That's my experience anyway. Epoxy really doesn't stick well to the outer surface of a wire. It sticks super well to copper, but it doesn't stick well to the vinyl, the PVC of which cable covers are made or wire covers are made. So depending on how much moisture you're willing to accept into your USB connection there, because basically what you're trying to do is waterproof the USB connection and the chips around it, right?
Yeah, I mean it doesn't have to be super waterproof.
So you're just weatherproofing it, okay?
Yeah, rather weatherproof, or I would want this. I would want to be able to stick the entire piece into the soil at depth.
Yep.
I want to detect moisture within a soil body, not just from the on the surface.
Is Ferdy, when he wants to do that, is there a better, because we didn't really talk about the material you're using to cast with. We just used epoxy, but if he uses something soft to cast with, like a silicon of some kind, a stiffer silicon or whatever, then he's going to be able to actually mold something that will actually stick to his wires.
Yeah.
So is there a good kind of epoxy for sticking to the PVC cover of his wires, or a good kind of silicon?
I started looking at the different silicones and resins we have in the lab yesterday, but I still haven't tried all of them, and I don't know them. They're like we have a lot, some of it which is quite old, but we have at least one that still works, so that's okay. And And the silicones, they have like different shorter hardnesses. Like the standard one that we have a lot of is like very soft. It's like 20, 30 shorter. But for something like this, you would rather want something with like 50, 60, like density, or like a skateboard wheel or like a shoe. Yeah, we have to check what we have in materials.
And the big trick, Kai, with your wires, I mean, for the board is no big deal. You can do whatever you want on the board. The hard part for you is going to be the wire, because it's going to wobble, it's going to move, it's going to bend. Yeah. And every time it does, it will work the mold a little bit more, and eventually you'll end up wicking right up along the wires. Mm-hmm. So if you can find a way to cast in a connector, like a rigid connector with a rubber piece on it, like you ever seen those the grommets you use on electric outdoor electric plugs? If you've ever seen those, they're like a screw-in piece that you have a. I don't know if I have any, but if you look at a fuse box, any fuse box typically will have these electrical connectors that they have a tightening down part on them. I'll send you a picture of one. Mm-hmm. And they have, or hang on, I've got one right here I can show you a picture of. And they come in all kinds of sizes, and they're designed specifically to clamp down on a cable. Mm-hmm. So here in my fuse box, you can sort of see, let's see now if I can get the picture right. Yeah, these aren't the greatest ones, but they're a sort of the wire comes out through the middle of a piece, and this bit here, there's a better one than this that actually has a screw down part on it. So you have the wire sticking out, and then you tighten a fitting over the top, which then makes it perfectly watertight. I think maybe my outdoor plug has one. Mm-hmm. No, it doesn't. It has something silly on it, but you can imagine what I mean. And then that way you use a piece of rubber to grip on your wires instead of trying to cast the wires into your part, because it just won't stick to the wire. That's not, the rest of it's easy, but the wire is just a nightmare.
Yeah.
I'm hoping, Ferdy, you had some solutions.
One last comment. Like, I don't want to discourage you of making this piece, but you might also want to consider doing something very simple in the just for getting into this thing. So, for example, if you go into Fusion, you make something the size of a coin, like the size of a €2 coin or a bit bigger, and you put a nice symbol on it, or you vectorize an ornament in Inkscape. You just like find something nice in black and white, and you extrude it in Fusion, so you have a little 3D surface. And if you pay attention that that the symbol is big enough so you can mill it with a 3mm end mill, you have a finished mold in like half an hour, and you have a finished working piece that you will pass FabAcademy with in half a day. And you already learned about all the little details that can go wrong. Yeah. So maybe instead of doing something like your part is not super complicated, but consider doing something super simple that you can do in one day before putting yourself in something that might take a week, and then you're still not finished.
Okay. The piece you want to do with your waterproofing your board, that's not really molding. You don't need to mold anything. You just need to make enough of a container around the end that you can stick it in. Yeah. But because it's overkill to make a really nice 2-part mold to fit your board in and then close it together and seal it. You don't need to do that. You just need to basically paint your board with epoxy.
If you wanted to do it well, you would need to make like two-part molds for making the upper and the lower case that you can then put together.
Yeah, and then you'd glue them together.
Past a gasket or just glue them together. And for this, for like a one-time piece, it's probably easier to just 3D print it with a piece of inner tube from a bicycle, and you're done.
Yeah. I love the way it's always random recycled parts with you, Ferdy. The inner tube from a bicycle. I don't have any of those just lying around. I throw
You
them
get them
away.
for free at any bike store.
It's the MacGyver kind of approach.
If you can't fix it with duct tape or inner tube or zip ties, it's not broken.
Chewing gum.
Yeah. It's just this is the number of people who end up in the hospital with burnt hands. Is
Okay. Yeah. Thanks.
Yeah, I hope this was like not too chaotic, but you can see that there's a lot to talk about in molding and casting, and we haven't even touched like two-sided molds or making copies of existing pieces yet. I would love to have the time for talking about this as well, but I think for the moment you should concentrate on finding something, a very simple model that you can design and generate the G-code for it in an hour or two, just like the Lego piece that I will upload you the video, and then then you like there's lots of little tricks that you have to learn for the whole process, and if you make a very complicated model and you have to learn the tricks with the risk of destroying work of a few days, then also it's going to be more fun if you start with something simple and do something more complicated in a second step.
okay. Cool.
Yes, thank you.
Yeah. No, thanks. That's
Yeah.
Okay. Any more questions?
I think I just need to get started.
Sure, but yeah, some sooner than later there will be more questions.
Yeah.
But thanks a lot.
Okay.
Cool.
Bye.
Cool. Great. Well, I'll see you guys later.
Bye-bye.
Tomorrow at 3. All right. Bye.
Thanks a lot, Fred.
Bye.
Beautiful introduction.